Hi guys. I'm Sabine, but call me Mr. Cell. Let me introduce my friends. Aisha, YY, A, Kosh, and Amin. So, today my friends are going to present about the receptor-mediated endocytosis of low-density lipoprotein, LDL.
Let me brief about it, guys. Definition: process of actively transporting molecules into the cell by engulfing it with its membrane. Function: receptor signaling, nutrient uptake, membrane remodeling, pathogen entry, neurotransmission, and modulating cell signaling process. Types: 3 different types: pinocytosis, receptor-mediated endocytosis, and phagocytosis.
Well, we don't have much time to discuss about the whole process of endocytosis. So, we are just going to explain about this particular topic.
Oh my gosh. It's my turn now. And soon it's my turn. I'm excited. So, let me talk about the lipoprotein first. A core, full of fat and cholesterol, along with a lipid membrane, that contains proteins called apolipoproteins. There are 2 types, low-density lipoprotein, LDL, and high-density lipoprotein, HDL. LDL cholesterol, are bad cholesterol, as it takes cholesterol to the arteries. Too much of cholesterol in artery walls may lead to atherosclerosis. HDL cholesterol are good cholesterol, as it transports cholesterol to the liver to be expelled from the body. HDL helps to read excess cholesterol, which may end up in the arteries.
As Kosh finished her part, my remaining members and I will explain about the process, while showing all of you an animated video. Hope everyone understand.
In this example of receptor-mediated endocytosis, a cell takes in a particle of low-density lipoprotein, or LDL, from the outside. To do this, the cell uses receptors that specifically recognize and bind to the LDL particle. The receptors are clustered together. An LDL particle contains 1,000 or more cholesterol molecules at its core. A monolayer of phospholipids surrounds the cholesterol and is embedded with proteins called ApoB. These ApoB proteins are specifically recognized by receptors in the cell's membrane. The receptors in the coated pit bind to the ApoB proteins on the LDL particle. The pit is reinforced by a lattice-like network of proteins called clathrin. Additional clathrin molecules then add to the lattice, which eventually pinches off a part of the membrane. This internalized vesicle is referred to as a coated vesicle. Inside the cell, the clathrin molecules dissociate from the vesicle and from each other, leaving an uncoated vesicle. Although not shown here, another vesicle then fuses with the uncoated vesicle, which causes the pH of the uncoated vesicle to drop. This drop in pH triggers the receptors to be released from the LDL particle. After the receptors are released, the vesicle carrying the LDL particle fuses with a lysosome. A lysosome carries enzymes capable of digesting the LDL particle into amino acids and fatty acids. At the same time, the cholesterol is released into the cytoplasm, and the cell either uses the cholesterol immediately or stores it for later. Meanwhile, the cell's LDL receptors are returned to the plasma membrane. Once in the plasma membrane, they can take in more LDL particles by receptor-mediated endocytosis.
Hence, that's all from us. Thank you for watching, and hope everyone understand.